Lesson 5.2, talking about the exterior angles of a polygon. So the exterior angle sum conjecture that we discovered from our investigation states that for any polygon, the sum of the measures of a set of exterior angles is 360 degrees. So it didn't matter if I had a quadrilateral, if I had a triangle, if I had a pentagon, hexagon, octagon, decagon, dodecagon, whatever. If I added up all of those exterior angles, it was always going to equal 360. All right, so that led us to some other measures. And basically, if I have a regular polygon, meaning all of the sides are the same, so it's equilateral, and all of the angles are the same, so it's equiangular, I could use these conjectures to help me figure out each individual angle on the interior, or each individual angle on the exterior, depending on the scenario. So the equiangular polygon conjecture states you can find the measures of each interior angle of an equiangular engon by using either of these formulas. So one of them was that you could figure out the exterior angles, divide it by however many sides you have, and then subtract that from 180. That it's based upon using linear pairs. And then, or the other option is you can figure out the sum of the interior angles using the polygon sum conjecture from 5.1, and then divide by the number of sides that you have, or the number of angles you have. So two possible ways to work with that. And it's just all going to depend on, are you given an exterior angle, or are you giving the total interior, or just given the shape? Let's take a look at an example of how we could use this type of problem in these conjectures to help us solve a problem. All right, so I'm going to pick another color. I don't know, that blue was a little hard to see, so let's go with nice obnoxious green color. All right, well, I want to figure out what E, G, F, and H are. So if I go in order, alphabetical order, oops, and I did not pick my color, let's try again. Seriously. There we go. E, F, G, H. All right, so there's a reason why we want to go in alphabetical order, just to make our lives a little bit easier. Now, notice over here on the left-hand side, I've got a pentagon, a regular pentagon. So since I know it's a pentagon, I can use the pentagon sum conjecture, which I already know means the sum of the 5 interior angles is going to equal 540 degrees. And then I can divide by 5, and I can determine from that each interior angle is 108 degrees. All right, well then using the linear pair conjecture, 180 minus 108, angle E is equal to 72 degrees. So that was pretty easy. And again, if you have the 540 degrees memorized, makes it simpler. If not, you can always just say 180, 5 minus 2, that gives you the 540, and then divide by 5 because you have the 5 angles. Now we're going to have to do this for the octagon on the right-hand side because I don't know the sum of the octagon angles. So 180, 8 sides minus 2 of those sides because we don't count the diagonals when we go side by side, and we're going to divide by 8. So type that into our calculator, and each angle is equal to 135 degrees. So each angle of a regular octagon is 135 degrees. Again, if you want to take the time to memorize some of these because you think you're going to be using them a lot, go for it. If not, don't worry about it. Use the formulas. It doesn't take very long to type it into the calculator and just go from there. All right, so angle F, of course, is a linear pair to that octagon angle. So 180 minus 135 is going to be equal to 45 degrees. I don't know where that line came from. All right. So we have the two easy ones. Now let's figure out angle G. So as we've worked in with our previous lesson, we have 3 angles that are forming a nice little circle right there. We know that the pentagon angle is 108 degrees, and we know that the octagon angle is 135. So add those two together, subtract from 360, and we see that angle G is equal to 117 degrees. All right, so now I have a quadrilateral hanging out here. So 1, 2, 3, 4 sides. That means the sum is equal to 360 degrees. Add E, F, and G together. Subtract from 360. And angle H is 126 degrees. Again, don't forget your degree symbol. That is your label. Oops, dropped the pen. I'm sure that made quite the racket. That's going to be it. And the only thing that would make this a proof is if for each step I justified y. So for angle E, for example, step 1, I had to figure out the interior angle. Oops. There we go. The interior angle of the pentagon is equal to 108 degrees. And the reason why was when we, oops, ran out of room there. Well, the reason why, so that's the first step, and the first reason was because of the pentagon-sun conjecture. Actually, not even the pentagon-sun conjecture, that was the interior angle conjecture. That was the whole point of 5.2. And then, number 2, angle E equaling 72 degrees is because it's a linear pair. So you have those 2 reasons. So step by step, do that for all 4 of the angles, and you have proven why your angle is the way it is. So sometimes you show your work mathematically, and then sometimes you show your work with words. All right, so again, make sure you finish up all of the assigned problems to help you prepare for your quiz, and I will be here to answer any questions.